There's that started. I'm going to mute everyone, and John, then I'll hand it over to you.
Sounds good. Okay, so we'll go ahead and get started. So for those of you who don't know me, I've been at Washington College about 20 years now. I came to start the program in archaeology, and then about a dozen years ago or so moved over into the Center for Environment and Society. But I was asked to talk about something that might be interesting and different. And so I actually picked a project that I was working on when I came to Washington College. It was just actually finishing it up. Prior to coming to the college, I had worked for a cultural resource management firm called R. Christopher Goodwin and Associates. And Goodwin and Associates, our office was out in Frederick, but we had another office in New Orleans, Louisiana, a couple of others around the country. And we got to work on some amazing projects. And in fact, my partner there was a guy named David Robinson. Dave may actually join us at some point during this conversation, but Dave is a superb archaeologist and a diver, also an expert in naval architecture. He's currently the underwater archaeologist for the state of Massachusetts. And we've remained in contact over the years, and a lot of what you're going to see could not have come about without Dave's help. So our story starts in actually 1995. And what I'm going to do is to share my screen and roll through a bunch of images that will allow us to see really what it is I'm talking about here. And so I've titled this The Last Shipwreck of the Civil War. I have to be honest with you, and I can't tell you for sure that it was the very last shipwreck of the Civil War, but it was certainly daggone close to it, as you will see. And the story for us really starts in around 1994, when a fisherman who was on the Red River in Louisiana, just below Shreveport, Louisiana, discovered some stuff coming out of the bank of the river. Now, it was at a low stage. As you may know, they control a lot of the water levels on these western rivers through dams and locks and the like. And he saw this iron stuff, and he immediately got interested, called a local historian, who you see there on the right, and the two of them dug some of this stuff out of the bank, and it was wrought iron. Now, they immediately realized that this was probably part of a steamboat. There are a variety of iron rods, turnbuckles, and other things that we'll take a look at here shortly that are signatures of these boats. And so they called the Army Corps of Engineers. You might not realize it, but the Army Corps of Engineers and all of their districts around the country actually have archaeologists on board. There's a variety of federal law and regulations that require them to take into account any impacts that their work might have on significant historic houses, on archaeological sites and the like. We happened as a firm to be under contract to the Vicksburg Corps of Engineers. And so they called us to take a look at what this might be, which again, they were mandated to do by law. So what we're going to do is to think then about what might have left these kinds of remains. We know that there were a variety of steamboats plying these western rivers. And in fact, you know, there are something like 900, almost 1,000 documented steamboat losses in about less than a half a century on western rivers. We also know that, in fact, their lifespan was relatively short, despite their importance to commerce and transportation in this area. Most of them only lasted about 4 to 5 years. It's worth thinking for a few minutes about why that might be the case. And you'll see some clues as we go along, but it's a remarkably short lifespan. They didn't all blow up. They didn't all catch fire. They had hazards to navigations. They ran a rough life. And so they weren't expected to last very long. It was an expensive endeavor, but nevertheless, you know, it returned a profit to those who ran these boats. Now, the location where this material was found and this wreck might have occurred was just below Shreveport. So what we're talking about is the Red River that you see in blue there that feeds down into the Mississippi. It was a major transportation route into the interior of the United States. And this is an aerial photograph showing you the area. That 16BO358 is the site number maintained by the state of Louisiana. And what you might be able to see here, and can you all see my cursor? Maybe John, if you can nod, if you see it. So, you know, you've got the main course of the river today flowing downstream to the bottom of the slide. And you can see all kinds of old oxbows, old channels of the river here. these rivers meander quite a bit. And if we zoom in on it, you can see it right here. And this is a drawing, a map of the area in which we were to investigate. Now, the reason the Corps was interested was that they had a navigation improvement project planned for this particular area. And you might be able to see this red line here. They were going to be putting in revetments, a large amount of stone, then with wing dikes. And what this does is to channel the flow of the river and maintain a deeper channel for navigation. They wanted to know whether or not their work was going to impact a wreck of historical significance. So a team from our Christopher Goodwin and Associates went down, started to do some diving in the river. We did depth finder or fathometer transects to try and see if there were anomalies, bumps on the bottom of the river that might indicate a wreck. We put divers in the water and did sweeps in sort of radiating circles. And we found a number of things. And you can see 3 buoys here labeled A, B, and C. And in fact, those were to mark the things that divers had actually encountered. You can partially see some of this right here. And I'm going to take away my, my images of all of you so that I can see this. But right in this area labeled A, we thought we found the stern of the boat. And there were a bunch of trees, there was barbed wire fencing, all kinds of other debris in here, but we also found what we thought might be the side of a vessel as well. Now, part of the difficulty in working in this particular area is the water's kind of murky. Nevertheless, we were able to draw a plan. Dave Robinson did this drawing, and this is some of that wreckage seen from above. What you've got at the bottom here is this dense, incredibly thick root mat. It was probably about 6 feet in height or better. And then down at about 20 feet in depth, to the best of my recollection, was this wreckage. And you can see a vertical post right here, and then this ironwork. This is a gudgeon for the rudder on a vessel, which tells us that we're dealing with the stern or the back end of a steamboat. This drawing also was enhanced by one seen from the side, and you can see that there are actually 2 gudgeons, one up here and one down below, and then this vertical stern post, and then siding of the vessel planking that disappeared into this incredibly dense mass of roots. So we realize here that we've got the end of a vessel that appears to then extend under the bank. And of course, there's the mouth of a creek right here, which is probably an old channel. So the question is, how big is this thing and where does it go? So the next step, which took place actually before I joined the company, was to bring in a coring rig. And by coring into the soil and going down 20 to 30 feet or more, they started to encounter some really pretty interesting stuff. Wherever you see a red dot here, they encountered wood. And it was interesting because there were 2 different layers of wood at least. And at the very lower levels, you found oak, really hard wood. In the upper levels, they were finding pine, fir, wood that's fairly light in weight. And even in some of the wood, there were embedded nails. So they were taking pretty good sized cores. So it looks like we've got a wreck that at least extends from this buoy A up here all the way down through here and probably into this channel. And for a little bit of additional information, we kind of tried to project this and then ran a magnetometer. And a magnetometer will detect buried ferrous metal, iron, steel, and got some huge signatures that you see depicted in red here. And that indicates that you've got machinery down there. We're probably talking about the boilers, the cylinders, and other machinery of this ship. You can see it there, and this is probably what we are dealing with. A side wheel paddle steamboat that plied the Red River and the Mississippi somewhere in the 1800s. And these were marvels of technology. So this immediately caught our attention. These vessels were really significant, very important for a couple of reasons. For one thing, they essentially opened up the interior of the United States. So, you know, not too far west of us, we run into the Appalachians, and we've got this mountain chain that makes transportation, at least by boat, difficult from east to west. But via the mouth of the Mississippi, you have access to the interior, up the Mississippi, up the Ohio, all the way to western Pennsylvania and Maryland and Virginia. And then, of course, you've got access all the way into the interior until you get to the Rocky Mountains. having a steamboat, a design that would ply these rivers, opened it up to settlement. It allowed people to get up and settle. It allowed goods to be imported to them, and it allowed them to get their farm products then to a commercial market. So from that standpoint, these boats were pretty significant. But in addition, there were challenges in doing this. And the innovations that came with having to navigate up rivers that had quite a current in them turned out to rely upon steam. So steam power was not new. It had been experimented with in the late 1600s, early 1700s, and even earlier. You can see an engine here called the Newcomen engine, which dates to about early 1700s, 1712 or so. And in essence, what you're doing is building a fire here, which you can see on this animated GIF, and then you're heating water, which turns to steam. Steam, of course, expands. You open a valve, which lets it into a piston and a cylinder. And that cylinder, with expanding steam, drives up a drive shaft. And then on a rocking beam, something like this, you can transfer that motive force to whatever it is you want to drive, whether it happens to be a pump or a wheel or a locomotive wheel or a paddle wheel on a steamboat. So this is the technology that they tried to adapt to all of these rivers in the United States at a very early date. Here's an example from our backyard. This is from the Chesapeake Bay. The Emma Giles was a famous steamboat that ran out of Baltimore. We know that these boats were important coming right up the Chester to Chestertown until after World War II. It really wasn't until the Bay Bridge was built that they started to phase out. But here you can see some of the salient characteristics. This big paddle wheel that you see at the center of the boat on the side of the vessel. And then this elaborate iron structure here is that rocking arm or walking beam. And then of course you've got the smokestack as well. Now the machinery for these things that you see in this model was pretty substantial. This is a little hand crank model in a museum, but you've got a cylinder right here that's big enough that a man can stand inside of it. Condensers, there's a drive shaft that's connected to the piston that moves this walking beam right here that is supported on a large, heavy iron A-frame. That then transfers to a crank, which then turns the wheel. Now this turned out to be incredibly successful. And what emerged was a whole class of steamboats that plied eastern rivers and the Atlantic seaboard using low pressure walking beam engines. And this is a wonderful drawing out of England. English engineers, and actually those from France and Russia and Germany and elsewhere, were very interested in this technology, came over and documented it. And you can see this heavy A-frame right here with the walking beam, and then all the engine machinery in the center there. This required an incredibly heavy framing, a very sturdy hull, and in addition, it meant that you had a very deep draft for most of these vessels. This, unfortunately, would not work on many of these Western rivers. Nevertheless, this technology took off. 1807, Fulton's Clermont was the first commercially successful boat to ply our river. It was up on the Hudson. Then we had vessels that were running up the Ohio, or down the Ohio and the Mississippi by 1811. By 1814, they were up the Red River. By 1817, there were 17 steamboats running between Ohio and New Orleans. And then by the time we get to mid-century, you've got over 700 vessels running those routes. But the problem is that Western rivers can be extremely shallow. Those Eastern steamboats simply wouldn't work. So American engineers and shipwrights got to work and came up with a solution. That solution was what they called a high pressure engine. It's not high pressure in today's terms, but at that time, 40 to 150 PSI was pretty significant. And they could reduce the size of the engine. It did not require a condenser. You could place it horizontally and connect it directly then to the paddle wheel. And that reduced weight with none of the A-frame, none of the walking beam, a much smaller cylinder system meant that you had a much lighter weight and you could get a lighter hull, even though there are some structural challenges in doing that. And what I'm trying to give you here is a sense of why these boats were really important. And unfortunately, we've got very little documentation of them. So that if you start looking for blueprints, if you look for half hulls, if you look for other plans like we see for many sailing vessels, they are simply scarce as hen's teeth. This is one, again, from the Institute of Naval Architects in London. They came over and looked at this. We don't know whether this was a real vessel or a fictional one, but you can kind of see it from the side here in the upper image. And then below, you can see a cross section, which shows you some of the longitudinal structure, and it shows you where the engines were. And so if we take a look at that, here is the cylinder and piston. This is a drive shaft connected to a pitman arm that then connects to a crank on the wheel, and that will turn the wheel around. So in essence, what happens is that this machinery moves back and forth, and it pushes that vessel forward, or if you reverse it, pushes it astern. The problem with this is that although you get an extremely light hull and very shallow draft, meaning that you can run up these rivers, and in fact, some observers said some of these steamboats could run on a heavy dew or float on a heavy dew, you have structural issues. These vessels will tend to sag in the stern and in the bow, and you need to stiffen them up. Some of these vessels were in excess of 200 feet long. So this structure here with these arches is what this artist depicted as some of that longitudinal stiffening. Frankly, we don't know if this was ever done. At least to the best of my knowledge, I've never seen that kind of thing in any evidence from an extant vessel. In addition, you've got this problem of the bow, which has less flotation, and the stern, which has less flotation, wanting to sag down, while the center part of the vessel has more buoyancy. So you get what's called hogging, where you can create this, essentially this arc in a vessel, which is counterproductive. So via a system of chains, actually iron rods and turnbuckles, over posts, they were able to distribute these weights. So by tightening this rod here, you could pull the stern up and pull the bow up, and you could transfer that force down via these posts to the more buoyant parts of the vessel. And this gave it the durability and the stability that was needed to lade them with heavy cargoes and move up and down these rivers. And you can see in a cross section here what it would have looked like. These are actually the boilers. The engines are behind them. These are the paddle wheels. And you've got multiple decks stacked high. So the main deck is actually primarily a working area and a cargo area. And then there are these guards that go out and extend cantilevered over the water. And we've seen pictures with bales of cotton, for example, that are stacked all the way up to here. So you can barely see the vessel, and the pilot could just see out of the pilot house on the top of the Texas. And they named these the main deck, the boiler deck, the Hurricane, the Texas, and so on. And so these were multi-story traveling steamboats that plied these western rivers. Whatever our wreck is, it's potentially significant because we know so little about how these boats were run, but especially how they were built and how they were designed. So that gave us a real interest in this, and the Corps decided that more work needed to be done. Question is, what vessel is this? Can we pin a name on it? Can we tell when it sank? How did it get there? How did it sink? So our team went into the archives and started pulling out maps and various other documents. This is a map showing the Red River in 1891, and you can see part of the dynamic of a river. This is the channel coming down from Shreveport, and a few years prior, it took a bend up in this direction and came around what was called Eagle's Bend, or Eagle Bend, and then came back down and joined the river. Gradually, this distance between these two curves got narrower and narrower until eventually it was cut off. And sometimes people actually encourage that. They would blow up one of these things to shorten the course of the river. This was called Latier's Cutoff. It was established in 1882. And so we can see that, in fact, our wreck exists on an old bend in the river where the channel was actually moving in this direction. Now, it turns out that there are lots of maps, and we did overlays, and you can see how the current path of the river differs from that historic path 100 years earlier. The reason this wreck was exposed was that it had come to rest here, had been completely covered over by sediment, so that it was under 20 to 30 feet of dirt. And gradually, the river is cutting back into it and starting to expose that stern. It's a remarkable dynamic, but it has enabled us to find a lot of wrecks that actually were once buried inland over time. More historic documents were uncovered, which actually, fortunately, gave us the identity of this wreck. This is called Latier Point at this time, and it's in the late 1800s. And in fact, there is a little image of a boat right here. And if we zero in on that, it's labeled the Wreck of Kentucky. So immediately that sets off the bells and you say, okay, what can we learn about the steamboat Kentucky? Is this something that was documented elsewhere? And the answer is yes. It was documented thoroughly. When a boat went into service, there were so-called enrollment papers. Those enrollment papers tell us that it was built in Cincinnati in 1856, went into service in July of that year. It was 222 feet long with a 32-foot beam. And in fact, we know that there were 52 staterooms, that there were men's and women's salons, there was a dining room. And this was a boat that was very fast when it first went into service, and it was in US mail service. Over time, its purposes changed, and gradually it got older, so that by the time the Civil War comes in the 1860s, you can see that it's pushing up against the maximum lifespan or average expected lifespan, certainly for one of these vessels. It turns out that very shortly after the outbreak of the war, a guy named Preston Lodwick bought the steamer Kentucky. He was located in Memphis, and he was a Union man. So he tried to escape by running the boat north. The Confederates stopped him. He abandoned the boat and escaped to Illinois on foot. The Confederates were going to burn the Kentucky, but fortunately for us, actually pressed it into service and started running it. Its chief engineer, a guy named John Keniston, took over. He also professed to be a Union man after the war, but it turns out that he ran the boat for the Confederacy for a couple of years through some very, very interesting service. The boat probably looked like this after it went into service, but once it enters into the Civil War, it had some exciting times. We know, for example, that in November of 1861, it spent 10 days and nights under fire, ferrying rebel troops across the Mississippi between Columbus, Kentucky, and Belmont, Missouri. Then a little bit later, in March of 1862, it was taking Confederate reinforcements to island number 10. This was the 10th island down the Mississippi from its confluence with the Ohio. And it was a scene of a tremendous fight for control of the Mississippi, with federal gunboats coming downriver and trying to take over these strategic points from the Confederacy. When Memphis fell in 1862, the Kentucky was captured. And it was then used by the Union. Lodwick, her original owner, tried to get her back in 1863. He finally managed to do that. And then he chartered it to the US Quartermaster Corps. And then in June of 1865, the Army of the Trans-Mississippi, which was in this part of the country, surrendered after Lee's surrender at Appomattox. And the boat was used to run prisoners, paroled Confederate prisoners, out of Shreveport down to New Orleans and then on to home. Now, we know a lot about this service because there was a lawsuit lodged by Lodwick against the United States after the war, where he tried to recoup money, $200 a day, for the 200 some days in which he was in federal service. In part of that lawsuit, he meticulously documented all of the details of the service of this particular boat. What he was a little bit light on, however, was her ignominious end, because it turns out that while ferrying paroled Confederate prisoners south from Shreveport, the boat sank. So it took on over 900 paroled Confederate prisoners, many of them from Missouri Battalion. Also took on a number of civilian passengers, took on the soldiers' baggage, a number of horses. And according to the accounts, it looks like the captain kept running after dark, after all of the other vessels that were transporting prisoners had tied up for the night. These rivers were not maintained the way they were during peacetime, so floating logs coming downriver created snags that could tear the bottom out of an unwary vessel. And it turns out that that is in fact what happened to the Kentucky. There are a number of accounts. This is one from a guy from Pindall's 9th Battalion of Missouri Sharpshooters, which were being transported by the Kentucky. And he says at 10 o'clock, the alarm was given that the boat was sinking. The greatest consternation prevailed among those on board. Suddenly aroused from sleep, rushed forth in their night clothes and leapt wildly into the angry waves. He thought he was actually going to drown in a cabin, and he talks about managing to find a hatch and getting up and then tearing a door off of its hinges, throwing it overboard and following it into the water, and he used it as a raft. He also talks about many a poor fellow who leapt off into the great crowd near the bow was dragged down by others in their dying struggles. So he paints kind of a lurid picture. There's much more to this quote. Then there is another observer who came down the next morning in another vessel and stated that the Kentucky sank last night and was an entire loss. About 100 persons perished, mostly Negroes and some children. One Missouri lady swam to shore with a child in her teeth. 15 of the brave sharpshooters were drowned. There was a vessel called the Colonel Chapin that came to the rescue of the Kentucky, tried to actually help pull it to safety unsuccessfully. And the captain of the Colonel Chapin observed that if I had the power, I would hang the captain and pilots to the first tree I could find. In his opinion, this was reckless and criminally foolhardy to be running this boat at night. And we can see the results right here. So this is actually a quite dramatic episode. One of the questions, of course, is to what extent are these reports accurate? There were Southern newspapers that reported this as a huge catastrophe with tremendous loss of life. Many implied that it was intentional on the part of the Union. But in fact, when we dig into the records, and we did so with a lot of detail, we think that there are about 30 deaths that we can document, and you can see them in that chart to the left, many of them from Pindle's sharpshooters. But we have a lot of difficulty because many passengers were not on a manifest and were not documented. So by all accounts, there were quite a few Black passengers who would have been on the main deck, probably hemmed in by machinery and by baggage, and it would have been extremely difficult for them to get off in that part of the vessel that went under the water first. There may have been as many as 50 deck passengers there who did not survive, along with 249 horses. We know that they embarked 250 horses and only one got away. So it's kind of a tragic episode, obviously, and it's something then that is part of the history of that closing of the Civil War in this part of the South. So what we have is clearly an important wreck. It holds clues to a rapidly evolving technology. It's got significant archaeology there, potentially. It's sort of a human tragedy. It's of historical importance, and so federal law required a full investigation before it was to be destroyed by this engineering project that the Corps was going to undertake. And we were retained then to do that work. So here's the excavation plan. And I don't know if Dave Robinson has joined us, but Dave and I came up with this, and we were both in great fear of our ability to carry this off, because first we wanted to install sheet piling, which I'll show you in a second, to fence the wreck off. You saw images earlier of trees that had come to rest along the wreckage. There was barbed wire fencing, all kinds of other debris. We didn't want that impeding divers. We didn't want certainly to have that kind of thing float down while we had divers in the water. We were then going to excavate and expose the stern of the wreck using a dredge. We were then to dismantle the stern and remove it. So we're talking about the likelihood of having to use hydraulic chainsaws in very low visibility. And then the Corps of Engineers did not have enough money to do the expensive conservation of the wreckage itself or of all the artifacts. So they were going to retain a sample, put it in a museum, and then the rest we were to put in a pit to be dug somewhere out here below the water table. So this material would be put underground and hopefully then preserved for the future when perhaps somebody had greater interest or had more money with which to work. So that was the plan. And we immediately got the Corps to go in and start installing sheet piling. This is the buoys that we talked about earlier. This is the mouth to that little creek, which is the old channel. You can see their machinery on barges at work, and they're driving this heavy sheet piling, these interlocking pieces of iron and steel that go in and fence off the site. Here you can see it in place with an opening here. And we were ready to go in 1996. We're going to come back the following season, and then there was a federal budget sequester. So we had to sit it out for a while until the budget was freed up. And unfortunately, over time, what happened was that there was a very, very bad storm season. And this is that river in full flood. You can see how chocolate brown it is. This is the area of the site. the sheet piling is underwater, and you can see that water has backed in here and created, in essence, a lake. And when we finally returned to the site in 1997, this is what we saw. So where we had been diving in 20 feet plus of water, it was entirely covered with silt and sediment. Gives you an idea of the load that these rivers carry as they come out of the interior of the United States. So what we had to do then was to use a large mechanical dredge to take off that overburden until we got close to the wreck, and we then went in by hand and removed the rest of the overburden much more carefully until we could expose this wreck and then start documenting it. So that becomes the province of diving. And if you're thinking about this, which is a site we worked on in Florida years ago, think again. In fact, the visibility is nothing like this. It's more like this. It's absolutely zero visibility. I don't know that I've ever been in water this black. Actually, I could put my hands into the water, cup them together, pull them out of the water, and would have a fistful of dirt. When we got under there, if we had a high intensity lamp on our head or on our mask, you could just about see your fingers in front of your mask, and that was pretty much it. So it required a different kind of diving. So here you can see how we set it up. We dove off of a barge. Here's part of our happy crew, used full face masks with surface supplied air, with communications. So this cable here, which is being tended to, has both compressed air that is going down into the masks, but it also has wires for comm gear. So there is a microphone and actually earphones in this mask. And so you can communicate back and forth to the surface. So for every diver that is in the water, there is a tender. There is also a rescue diver in case they run into trouble. Remember, we're working around wreckage here. There is somebody taking notes. There is also somebody on a communications gear, and then there are other people doing a variety of other tasks. So if we have more than one diver in the water, we've got to multiply that crew by a little bit. Here's the communication systems, but it's an extremely efficient way to do this kind of work. And of course, divers can stay down longer when they're surface supplied in that fashion. So here's Dave and JB Pelletier, another member of our crew, who are taking measurements in the field and doing this large scale drawing of the wreck, which emerged piece by piece. So if you think about this, what we're doing is taking one measurement at a time and relaying it to the surface. Working off of a known point, which is the stern post right here, we stretched a measuring tape right up the longitudinal axis of the vessel. And we could kind of feel where the keel and the keelson were, and we ran this straight up along that line. We could then measure to either side off of that line to get individual frames or the ribs of the vessel, as well as the individual planking. How do you take a measurement in zero visibility? Well, you take the zero end and put it on one side of what you're measuring. You then take your thumb and run it to the other side where there should be a measurement visible. Of course, it's too dark to see it. You then put your thumb right up to your face mask, less than an inch away, and under that high intensity light, you can just make out the number and you relay that to the surface. So measurement by measurement, point by point, a picture of this vessel starts to emerge. We're uncovering it by dredging. That dredged material is likely to have artifacts in it, so that effluent all goes into screens, which then allow you to recover those materials, which are essentially invisible when they're down on the bottom. Here you can see the gradual shape of the stern emerging. Here you've got, again, that stern post, the keelson, then a large A-shaped piece of wood. It's an upside down A, which is called a stern hook. That provides stability and reinforcement to the stern. The stern and the bow are the weakest parts of pretty much any vessel. And then shackled into the keelson here, you've got this big wrought iron piece, which is one of those hogging chains. We described those earlier. That's what allows you to pull up the stern of the vessel and transfer that weight and that force down over a post in the center of the vessel. So gradually this picture is starting to emerge. We could then start to dismantle sections of it, like the stern hook, that A-frame, bring it to the surface where you can photograph it, draw it with greater detail, and eventually conserve it. But a lot more detail is visible when you raise it to the surface. But this is a time-consuming and laborious process. The area between these frames was used, in essence, those of you who have done archaeology know that we dig in squares according to a grid. You can't really do that here in this circumstance. So we use the space between the frames as our provenience control. So, you know, you're going down layer by layer between those frames. And then as we get farther up the vessel, that distance becomes greater. So we do it port side and starboard side. So port and then starboard. And all of those materials are collected together so that you can see some sort of patterning potentially in the distribution of artifacts on this wreckage when all is said and done. And as we move even farther forward towards the bank, parts of the main deck, which are raised up much, much higher than this interior portion, start to become visible. In fact, we first noticed that when one of us was digging under here and called time. It was time to stop the dredge and go back up to the surface to change out another diver. And the diver hit his head on this deck beam right here because he'd actually dug underneath the decking here. So gradually a picture of this vessel is emerging. And then we started to find materials on top of that deck. An anchor, which you can see in this drawing right here. You can say actually parts of the framing here. And what we're doing is drawing in even these deck planks one by one. Again, measuring out from the center line, taking that measurement, that measurement, that measurement, and then actually feeling for where the nails were and putting those onto the plan as well. And so gradually these materials start to emerge. In addition to the anchor, we started seeing cast iron cookware. Here's the anchor itself. We found part of the bilge pump. You can see an opening in the deck right here. In order to get the water that leaks into a vessel, either from over the sides or through the planking, you have to periodically pump it out. Here's part of the bilge pump drawn after it was excavated and removed and conserved. We also, underneath the center of this thing, below the main deck, started to find X bracing, longitudinal bracing. So you may remember on that earlier image I showed you from the Institute of Naval Architects in London, we saw those arches. This is the equivalent on this vessel, and it ran up the center line. And here are some drawings that we did after the fact to show you essentially how this was put together. So it provides an incredibly functional stiffening with relatively little weight. And it's a technique that then later becomes adopted on boxcars, on railroad cars, on bridges, on a variety of other things. Or they're stealing the ideas here from that kind of technology. But it is the functional equivalent of what you see on this hypothetical image right here where you've got the arches. So this is a detail that was pretty important for us. As we gradually went out to the sides, we also found those guards that hang over the edges of the water, and to keep them from sagging, they had the same kinds of iron rods with turnbuckles that would hold them up as it sagged. You could tighten the chain a bit. You can see that right here. This is one of those turnbuckles. This is all wrought iron. And then, on a much, much larger scale than what we're accustomed to buying in the hardware store today. All of these details are pretty important. And I think this gives you an idea of, I got to get a better image of this, a crisper one, but this shows you again that stern post with the gudgeons that we talked about first. Then you can see the hull planking. And then this is the main deck that gradually emerged with the anchor sitting on top of it and other debris. And you get an idea of the size here with the driver to scale. So one of our guys, a guy named Adam Kane, did this drawing, which is a pretty nice image. Of course, we never got to see it like this because there was zero visibility. This is all put together from the measurements that were done during the course of this project. Last thing to do was then to get the curvature of the frames themselves, which obviously are more acute as you go towards the bow or the stern, and then flare out and get broader as you go amidships. And there are a variety of ways of doing that we can talk about later if you have an interest, but in any case, we were able to document the curvature of those frames. That gives you then an idea of what the shape of the hull was like and how this boat was put together and how it was designed. In terms of artifact recovery, I can go through a number of these things quickly. Cartridges, this is buckshot and ball tied into a cartridge for one of these Confederate weapons. Here are percussion caps. This was the successor to flintlocks. So instead of finding flints as we do on Revolutionary War sites or earlier sites, you find these percussion caps. Got a variety of buttons, both civilian and military. That I is for Confederate infantry. In addition, personal items, a medicinal vial, part of a pipe with a silver or pewter bottom to it. And then that cast iron cookware that I mentioned earlier, actually a whole range of this material. It was really pretty fascinating to see that come up. This was later conserved so that it is preserved for posterity. But you can imagine that that is probably part of the baggage of the 9th Missouri, which lost most of their materials. They escaped in their night clothes or in their clothing, and that's really about it. Also, regrettably, part of the mandible of a horse. So we did find evidence of those 249 horses that were lost. To best my recollection, there was also some harness bits and other materials. Fortunately for us, no human remains, so that was not something that we encountered. Now, part of the problem here is that we've uncovered all of this material. We've documented as best we can. The next stage was then to cut it apart and actually raise it to the surface, which has all kinds of inherent problems and dangers in it. The engineers who had worked on this project were adamant that this could not change, that they could not re-engineer this. They had to do it as it stood, and therefore we would have to remove that material. However, we got them down to the site one day. They were there with the district engineer, and he had all of his buddies out there on the dive platform that you saw, that barge. And it was like June bugs on a skillet. This was in July or August. It was as hot as I can ever remember it being. These guys were sweating buckets, and you could tell they did not want to be there at all. But they came down, they started looking at the plans that were emerging. They saw the process. We told them about the history of the wreck. And before you know it, they were caught, hook, line, and sinker. And their boss wanted them out of there, but they were having none of it. They actually got out plans and started re-engineering right there on the site and ultimately told us, look, this is too important. This is a war grave. It's historically significant. We can't damage this thing. What we'll do is move that revetment center line outward. And you just finish your work, document everything you can, and then we will come in and we will fill it with clean sand on top of it, cap it off. It'll be preserved behind the revetment, and it'll be there for posterity. And that was music to our ears because it absolved us from the necessity of cutting this whole thing apart and trying to remove it. And it actually allowed us to concentrate on exposing as much of the wreckage as we possibly could. So it was a really good solution ultimately. And that engineering project, that navigation project has been completed. And there are tons and tons of stone all up and down this portion of the river. But the wreck of the Kentucky is nicely entombed behind all of that immovable material. As a result of this, based on both our documentation and the historic documents, we were able to put together a beautiful picture, I think, that's probably fairly accurate of what the Kentucky looked like. And particularly in the stern, which is where we had the best evidence, that hull shape is very, very accurate. And in fact, we were able to put together a model for the core of the poor Kentucky sailing downriver, hitting a submerged snag, tearing the bottom out, and then eventually coming to rest on the bottom. But the importance of this goes way beyond that. You know, there's evidence of really innovative engineering here, solutions to problems that were novel. We know that there is a lot of technological transfer that goes back and forth between various realms of construction and industry. So you can see the same kind of solution that was used for the longitudinal stiffening on the Kentucky, used on railroad trestles, in boxcars, in other kinds of bridges. And in addition, we've sort of filled in, I think, an important element in the history of steamboating, not just the wreck of the Kentucky, but also of the people and even the horses that were on board, as well as all of the personal objects that they carried with them on board. So for me, it was a really fascinating problem to work with. I think it was also a really interesting historical and archaeological puzzle to resolve. And I think that it has enhanced our understanding of these vessels enormously. And so it was one of those once in a lifetime opportunities really to dig a wreck like this. We always think of underwater archaeologists as digging, you know, these time capsules, but most of the time we spend trying to find them. Very infrequently do we actually get to excavate them to the extent that we did here. However, keep in mind that we only excavated the stern. The rest of that vessel is there, buried under 30 feet of dirt. All the machinery's there, the engines, the boilers. all of the other machinery, and God knows what all kinds of, what kinds of personal effects as well. But that is the story for a future time and for a future generation. So that's what I have for you, and I am happy to take questions at this point.
So what I'd like to do is invite anyone who wants to post a question in the comments section, or post your name, post that you have a question, and we can call on people while you think about that. I actually have one. John, you mentioned a magnetometer?
Yeah, magnetometer. Yep.
Magnetometer. There's a mouthful. What is that like? I'm surprised nobody has tried to scan the entire Mississippi, given its importance, as a route for commerce and exploration.
A good bit of the Mississippi actually has been surveyed. So a magnetometer is, I guess it's I shouldn't say this, but it's in a way like a very sophisticated metal detector. And they make them for land and they make them underwater. We actually have both at Washington College. What they do is, through a variety of techniques, they detect anomalies in the Earth's magnetic field. So under normal circumstances, barring some sort of geological source of iron, barring an electrical cable or anything else, you will have an ambient magnetic field for any given spot on the Earth's surface. There are various things that people do which will change that magnetic field. So for example, if I burn a fire, that creates what we call an anomaly. It actually changes the magnetic properties of the soil to an extent that we can detect it with a magnetometer. If you think about a big piece of iron, like a cannon, or in this case, a cylinder or piston or the boilers, those are huge metal objects. And when that iron is molten, it's got a lot of magnetic domains in it that all align to wherever magnetic north is at that time. And when that molten iron cools, all of those magnetic particles, you can think of them like needles on a magnetic compass, are pointing towards magnetic north. Collectively, they create a detectable anomaly that a magnetometer will pick up. So basically what we'll see is, if you can think of it, as you're moving along, you have this baseline, right, which is ambient magnetic field, and boom, you get this, it could be a monopole or a dipole, you get various signatures. There's something there. Now, the question, of course, is it man-made? Is it something natural? And there are various ways in which we can get to the bottom of that. So typically we'll use magnetometers. Looking for shipwrecks, you might use side scan sonar. That'll only detect something that sits on or above the bottom, but there are a variety of tools like that can be used.
That's really interesting. I don't know about any of this stuff, so thank you.
And then we've done portions of the Chester River with both magnetometry and side scan sonar. It's one of those things that our students can learn, which is terrific.
Fanny Shank, I see that you have a question. I'm going to unmute you. Would you like to share it with the class?
Oh, okay. Can you hear me now?
Yes.
So, John, I was interesting that you found a piece of the horse's bones, but why do you think there weren't more human remains around? Was everyone accounted for immediately after the sinking?
It's hard to know the answer to that for sure. I can tell you, I suspect, there are accounts afterward of bodies being pulled ashore and buried. So we know that some of the fatalities, the bodies were recovered. Our strong suspicion is that there were quite a few people who were trapped on the main deck, and their bodies were likely trapped there as well. I just don't think we got far enough forward to find any of that. And I think that the horses may have been farther forward as well. Frankly, I'm glad we did not. It's an interesting sidebar. When we got down there, all of a sudden there was a stink in the local papers because a local historian, whose thing was the Red River campaign and this part of the Civil War, I think had his nose out of joint that, we hadn't consulted with him. And so he got a hold of the Sons of the Confederate Veterans, and oh my God, they raised a real stink about us, carpetbaggers coming down and molesting this, war grave. So we had to do a public meeting, and then actually I figured out the quickest way to diffuse the whole thing was to hire him as a consultant, and then the problem went away.
I see.
So no, we did not encounter any human remains, fortunately.
But that doesn't mean they're not there. They're just.
I'm sure they still are there. So they're further under the bank there.
I see.
Is my guess. So I see Beth had a question about the Texas part of the Kentucky catching fire. Did we find any evidence of it? And the answer is no, we didn't find any evidence. But imagine the chaos that ensues. This boat hits a snag. It starts to take on water. The captain and the crew don't realize it's taking on water until it's pretty much too late. They try to head to shore, but don't make it. And the boat careens, so it tips over to the side. When it tipped over to the side, apparently at least one oil lamp, which was lit, fell off, crashed, and then spread a fire. And so they were also trying to put that fire out at the same time that they were trying to deal with, the chaos that ensued from a nighttime crash like this or wreck like this. It must have been absolutely horrifying to people who had no idea what was happening, particularly if you woke up to this, right? I mean, if you were awake, maybe it was one thing, but if you woke up to this noise, this din, and the vessel lurching to a side, I can't imagine what it must have been like.
And it's dark.
It's dark, yeah, absolutely. There are no lights on shore, and very few on the vessel itself. And then, of course, those are breaking and spreading fire around you. Then you have light, but not the kind you want. So somebody asked, what were the woods used to build this ship with Costanza?
That's me.
Yeah. So it's interesting. Now, keep in mind the conflicting demands you have on a vessel like this. On the one hand, you want it to be durable enough, hardy enough that it can withstand the weight and the loads that you put on it, both from the machinery and then especially from the cargoes that you put on, because people weren't the only cargo here, particularly later in the lifespan of these things. If you're putting cotton and dry goods on them, it gets pretty heavy. And then you've also got the stress of these rivers where you have shallows, where sometimes they may touch bottom. You have to have a hull that will withstand all of that. Yet at the same time, it has to be lightweight enough that you don't draw so much water that you just can't get up these shallow rivers. So it seems like what they're doing is using very hard, durable woods like oak for the framing and perhaps some of the planking. But when you get into that superstructure, when you're up on the Hurricane, when you're on the Texas, you're talking about much, much lighter weight woods. And so those lighter weight woods are going to be softer, less durable, but those also are going to take less stress, and you can also rebuild them if you have to. So there are plenty of instances where actually a boat sinks, and they then raise it, pump the water out, put the engine back into service, and rebuild the superstructure. So I've got pictures of that kind of thing happening. So it's really pretty fascinating.
Well, I was impressed with the part of the stern that you brought out, the V part, that was in really good condition. I mean, you couldn't buy that wood at Lowe's, but
that's right.
It had survived well.
Well, there was rope too. I mean, in a little cavity back there at the stern, we found coils of rope that were perfectly well preserved. And those were brought out. Dave Robinson is a great conservator too. And so actually we rented a house, which was our quarters for the several months we were doing this. And I'm sure the neighbors thought we were absolutely out of our minds because we had the backyard filled with kiddie pools that we were changing the water in every day with, all of these artifacts because you try and keep them wet. And actually sometimes they start to stink too. So I'm sure we were lousy neighbors. But there is a depiction of them trying to get a rope off of the stern of the boat to pull it ashore, and the rope broke. So, whether we encountered the same line or not, I don't know. It's nice to think that we did, but so the preservation was pretty remarkable. I can't imagine what it must be like further in, under the encapsulation of soil that it now rests in. It's got to have some wonderful, wonderful things in there.
John, Beth asks, are any of the artifacts on display now, and if so, where?
They are, and I'm ashamed to say I've not been down to see them, but the Corps of Engineers has a small museum somewhere down there in Shreveport. And shame on me, I knew this question would come up. And I thought, so you ought to take a look and see where the heck it is. But, we'll all have to Google where it is, and then I got to take a road trip at some point. So Paul Johnson, hey Paul, welcome. Asking if any plans exist for future work on the Kentucky. Not that I'm aware of. It's preserved now. It's in place. The Corps of Engineers and the state of Louisiana knows where it is. And I don't think anybody has any money, regrettably. So, under In a perfect world, I would love to have sunk some exploratory excavation units on land and seen what we got, but nobody had any money for that. And they certainly did not have the money for conservation. You know, and the conservation is a real issue here that most people don't appreciate, because on land, you know, when we dig up artifacts, if you think about an object that's made out of iron or some other material and it goes into the ground, corrosion starts. Over time, as it gets sealed up, that corrosion slows down. If we bring that iron artifact up to the surface, and I'm just using that as one example, and expose it to air again, the corrosion process speeds up almost exponentially. And so I've seen plenty of examples of people who are out there with their own metal detectors, or, you know, doing treasure diving, as they call it, you know, bringing up objects from shipwrecks. And they think they've got this beautiful mantelpiece or coffee table piece, and they bring it up and it's of iron, and it could be, you know, of course you don't put a cannon on your coffee table, but you get my drift. And eventually this material just shatters apart, and you end up with a pile of dust because the materials have completely corroded. In order to prevent that, we have to stop the corrosion. We got to get the salts out of it, and we have to seal it from the atmosphere. That takes a concerted effort, and it can take many, many years. The same is true of wood. You know, that wood, the internal constituents of it and the cells have been, you know, what was there originally have been replaced with water. And if it's allowed to dry off or dry out, it essentially implodes, and it can be maybe the third of its original shape and twisted almost unrecognizably, again, unless you conserve it. So that conservation is an incredibly time-consuming and expensive endeavor. And the worst part about this project for me, as it was originally conceived, was the notion of disassembling a lot of this wreckage and then reburying materials on site. It's been done before, and we were going to put in sampling tubes so that we could monitor biological activity, and if we found that there was deterioration taking place, do something about it. But that's never a good outcome. It's much better to only bring to the surface those things that you know you can deal with and adequately preserve for the future. Paul knows this better than anybody, so. Would ground penetrating radar work for the land portion of this wreck? Absolutely, yeah, it could. I mean, you know, a lot depends on soil conditions, other variables, but yeah, I would imagine it would work quite well. Have I heard of hand cell on the Nanticoke River in Vienna, Maryland? No, I have not. Oh, my wife has in the background here.
Sorry.
Other questions? What have we got here?
Hello?
Yes, I can hear you.
Okay, I'm sorry, I lost you. I spoke with George Spillick, who recommended that I contact you about Hansel,
okay,
Vienna, because they are doing a big dig. They're finding Indian slaves and a boat in the river.
oh,
And the house that they are saving was designed by the same architect from Annapolis or wherever that did all the Washington College
okay,
architecture. So while I try to make a sales pitch for this,
that's great.
There is a connection, and George Spillick told me I should tell you about it.
Great, I'll find out more about it. My wife, Liz, who's here in the background, is the director of our public archaeology laboratory, and she just told me that she knows about it. So we'll confer. It sounds fascinating. Okay.
It's a little in the rough stages, but you know, that's where best part to start. That's
great. That's great. Thank you. We will look into it.
So it seems like questions have quieted out. I know we're right up against 1 o'clock. I want to thank everyone who was able to join us today, and thank you, Dr. Seidel, for opening up this conversation. It's been a real pleasure to see so many people engaged with it. As I said at the top, I'm going to post this recording later today on the alumni website. If you enjoyed today's class, I encourage you to share the link with friends and fellow alumni. Really grateful to the professors like Dr. Seidel who have been willing to host these classes for the last several weeks. You may know the semester at WC is wrapped up, and our alumni classes are going to take a summer hiatus as well. Our plan is to put together a fall lineup of classes and continue these as a service to our alumni. If you have topics or speakers you'd especially like to hear, or if you have an experience you think would be of special interest to the community, please reach out. You can DM us on any of our social media or email us at alumni_office@washcall.edu.
If I can do a quick PSA.
Please.
Because I've got alumni on board here. We are going to launch a new program this fall that may be of interest, and we'd love your assistance in publicizing it. Our graduates this year are emerging into an incredibly bad job market, as you might expect. And what we're going to try and do is to help them. So if they're without a job, if they're trying to develop skills and keep occupied, we're going to run something we're calling the Competitive Advantage Initiative. And we've got about 20 modules that are mostly about 3 weeks in length, some a little bit longer, that are designed to teach practical skills, everything from finance and budgeting to proposal writing to communications, and then technical skills like remote sensing with magnetometers and side scan sonar. And these will be available at a nominal cost. We're going to launch an announcement in a week or two, and we'll have a registration thing up online. It's open to any graduate of Washington College, certainly, even though we are focused really on those who are trying to enter this terrible job market. So if you could help us publicize that, I'd be greatly appreciative. I also said hi to a number of you. I want to say hi to Roland. I haven't seen you in a long, long time. Hey, Barb. Hi, Madison. Glad you guys are on board. Thank all of you for joining us. This has been a lot of fun. I appreciate it.
Thank you.
Thank you very much.
Thanks.
Great work. Thanks, Doc.
Thanks, John. Say hi to Liz.
Will do.